We'll proceed in tedious calculus problems. Tedious calculus problems in which we are pursuing the discussion. Tedious calculus problem. And the we are in phase of calculating the surface area. We have calculated the curve length. Curve length successfully. We have calculated the curve length. Now we are in phase of calculating the surface area. How to calculate curve length? Curve length is the way, there are two ways. Okay, one is primitive calculus. In phase of primitive calculus, if someone is calculating curve length, then better write a pseudocode. What are the steps you would take to calculate the curve length? That is called pseudocode. And in that pseudocode, rather than taking a curve length, we try to calculate line length. Line length. If this is x-axis, this is the line. If this is the line, what is the length of the line? What is the end point of the line? End of the point line is x comma y. This point is origin. What is its length? Okay, then fundamental is try to get vector notation of it. Then vector notation is xi plus yj. Then length is x square plus y square square root. Anyway, it does not fall in calculus in a way that there will be a problem when things are variable. If it is a static, x and y has a static value, it's all right. Otherwise, it will have a problem. In that sense, the kind of way to calculate the line length of any line is take x equal to 1. Take x equal to 1. Here x equal to x we took. X equal to 0, x equal to x. If I go up and it hits the line here, and that is x comma y. Take x equal to 1 and go up, then it will hit the line here. This point is 1 comma y by x. This point is 1 comma y by x. Calculate the vector of it. A line that passes to origin and 1 comma y by x, the vector would be I plus y by xj. Calculate the length of this vector, that is 1 square plus y by x whole square root. This is the magnitude of vector. Now, since we calculated it for 1 in x, multiply to the x, you get the net length. Net length is now 1 square plus y by x whole square root into x. Now, this we have to transform into calculus. Calculus in the sense, if I find any division where numerator is dependent upon denominator, it is a candidate. Numerator is dependent upon denominator, certainly it will be algebra, certainly. And then dependency and independency is there. Now, in that scenario, it is a candidate of differentiation. If there are multiplication of two items and one item is dependent upon other item, then it is candidate of integral calculus. Integral calculus means calculation of the multiplication will not be through repeated addition, but it will be through the drawing a graph and calculating the area. By calculating the area also, we calculate the multiplication. So that way we will go through. So now in that sense, 1 plus y by x whole square root, that is the length of the vector where x is 1 into x. It transforms into 1 plus dy by dx whole square root. Y by x change into dy by dx. Now this whole term multiplied by x. This whole term is dependent upon x. Dy by dx will come in a form of x only. So whole form 1 plus dy by dx whole square root will be dependent upon x. Multiplication, it is candidate for integral calculus. So net length of a line, that is from origin to x comma y, is 1 plus dy by dx whole square. 1 square plus dy by dx whole square root dx. Now x is from 0 to x or whatever someone wants. Amazing, mind blowing. Can someone believe this? This is the actual term. And with this fundamental, we can calculate the length of a line, that is y equal to x square. If this is x axis, this is y equal to x square. If this is y equal to x square, what is the length of this curve from origin? And this curve is up to x. This line is up. This line is origin to x. From x, if someone goes up, it hits here. This point is x comma y. This point is x comma y. If this point is x comma y, what is length of this curve? I cannot go from origin and x comma y, x square plus y square root. This is a curve. Okay, in that fashion, we have to think about in a fashion. Now I fashion. Now what we have achieved is 1 plus dy by dx whole square root into dx. Okay, this will tackle. This is a like a pseudocode. The actual pseudocode to get the line length is 1 plus 1 square plus y by x whole square root into x. Now, when the line is not smooth, in that sense, y by x is not same. Everywhere y by x is different. If it is a straight line, then everywhere height by width is same. It's a numeric value. But if it is a curve, everywhere y by x, everywhere y by x is different. That is the change. That is the difference between a straight line and a curved line. If you take a straight line, then take any point. If someone takes a straight line, this is x-axis. If someone takes a straight line, then any moment, if you have y and x divided, then you take any y and x divided, it will be same. But if it is not a straight line, y y by x, everywhere y by x will be different. Okay, then y by x is different, so we need to do something else. But anyway, we have y by x here in the computation where y is dependent upon x, y equal to x square. That is the formula, y equal to x square. If that is the scenario, then we can happily say y is dependent upon denominator x, and it is algebra dy by dx, and then into x at the end dx. Now it will take care of everything because we are sitting on top of variable algebra and achieving the division and integration through graph way, not through summation and subtraction. Through graph way, we are calculating the multiplication and division. So this is the miniature one. Okay, so this is the net kind of curve length. Anyway, we are in phase of calculating the surface area of a sphere. This is a sphere. Okay, this is this is a sphere. This is a sphere. If this is a sphere, what is the surface area of the sphere? If it was a rectangle, then we could have calculated the surface area. When writing the pseudocode, take the simplest example. When writing the pseudocode, we take the simplest example. So, we are taking a kind of a rectangle. Okay, consider this is a rectangle and this is sitting on top of xy plane. This is x-axis and this is y-axis. This is origin. What is area of this? Area of this is this line into this line. More specifically, this line, if I represent this line as a vector, making sure that this line is parallel to this line and this line is parallel to this line. In that sense, the area underneath will be cross product of two lines, this line and this line. If I make cross product, it will give the area. If it is sitting on xy plane, then this line is xi and this line is yj. Cross product of xi plus yj is the net area and it will have area vector also. That is xy k vector. Okay, now idea is that if I tilt it like this, first we keep y-axis constant and then we tilt like this. Then we keep x-axis constant and tilt like this. What is area of this? do whatever you want. If it is a rectangle or if it is a parallelogram, whatever, that is a special case. We always, when we write pseudocode, we always take the simplest case. So if it is a rectangle or whatever, if two sides are parallel and these two sides are parallel, if this is A vector and this is B vector, cross product of A and B will give the area. Now it is up to you, you find the A and B. If it was sitting on xy plane, then A was xi and y and B was yj. If it is like this, then A is certainly not xi, it is not in I direction, and B is certainly not yj. Then what is ai plus yj? Okay, that is the scenario. Okay, very nice. That we will see. What we saw in two dimensions. The net length of the curve is the vector representation of a curve or a line. Net length of a line is a vector representation of a line where x is 1, then height is y by x. Okay, in that sense, what is the length? What is the vector representation of a point that is 1 comma y by x? That is I plus y by x j. Okay, if it is like that, then we calculate the magnitude of that vector and multiply it by x. The idea is to find the length of a line where one point is origin and another point is x comma y. Here we are trying to find a surface area where one point is 0 comma 0 comma 0, that is origin, and another point is x comma y comma z. In that sense, there the independent component was x-axis. Here independent component is x-axis and y-axis. Rather, we will say independent component is xy plane. Now take, if this is the surface, then this is xy plane. Earlier it was sitting on xy plane. Now this is xy plane. On xy plane from the origin, if this is the origin, from origin take one area, that area is 1. Okay, and like x is 1 and y is 1. Now take one point here where x is 1, y is 1 on the xy plane and take up. So this is x-axis, this is y-axis, this is z-axis. Take any point on xy plane as 1 comma 1 and go up till it hits the surface. Take the, register that point, what that point is. If that point is here, then this is origin. What is the area of this surface, small surface? Multiply it by x. Multiply, if this is like this, then what is x? If this end point is x comma y comma z. If I draw a vertical line here on xy plane, whatever is x from origin, whatever is the x on the x-axis side, that is x. Similarly, that is y. So take x as 1, y as 1. Take x 1 comma 1 1 on xy plane. Go up and it will hit a point on the surface. And there that point is P. Calculate the area of this P. This may not be 1 because one area I had taken on xy plane. From origin, take a 1 area. Area is 1. That is x is 1, y is 1. Take 1 as area on xy plane. Take the end point 1 comma 1. Go up and see where it hits. Take the area, multiply it by x into y. So I'm sorry, multiply it by x. This is not x. Here, if this point is x comma y comma z, here if I go down, then on x-axis that is x. If I go down on y-axis, it is y. Now multiply with the x and y, not this length or this length. Okay, wherever it is making intersection on xy plane. So if this point is making intersection here, that intersection is x comma y. If this point is x, y, z, then multiply with the x and y. That is the net surface area of this. Okay, that is pseudocode. Now pseudocode is, now if I take this point, if I go one x-axis 1, y-axis 1 and take one point here that is 1 comma 1, go up and it hits here. If it hits here, that point is P. That point is P. Okay, if that point is P, then how we calculate this small surface area? Then I have to calculate the surface area. I need to have two vectors. If it forms if this is origin, if this is origin and if this is origin and this is xy plane, on xy plane I take a point 1 comma 1 and go up and it hits a point here, then it makes a surface area here. To calculate the surface area here, we have two sides. One side is this and one side is this. Okay, now calculate the vector notation of this and vector notation of this and calculate the cross product. Make sense? In that sense, if I have a x equal to 1, x equal to 1, I take xz plane. Okay, this, if I like do like this way, first this is sitting on xy plane. Now keeping the y axis constant, I shift it like this. Okay, then keeping xy, new xy axis constant, I shift it like this. Okay, if that is the sense, if that is the case, or someone can think if this is the kind of whatever it is. The idea is this this line, this line, keeping this, I mean keeping this constant, I am moving this axis like this. Now this line and this line, from this side this line. Okay, it looks little bit convoluted, but make it straightforward. Now consider the new point that is coming here P, the new point that is coming here P, it has Z value, certainly. It has Z value and X is 1 and Y is 1. Okay, if that is the case, then I can have two planes here, XZ plane and YZ plane. There are two lines that is represented. One line is this. If I do like this and like this, if there is, I'm trying to calculate a surface area at point P to the origin, what is the rectangle it makes? The P is 1 comma 1 comma Z. 1 comma 1 comma Z. Okay, in that sense, if I come this side, hope, this side, then it is like this. If like this, like this. If I see this side, then it is like this. Again like this. Hope, like this. Means there the two side of this, the two side of this, what I'm trying to calculate, I would repeat it. I'm trying to calculate surface area of this, where the end point is P, that is x comma y comma z, and begin point is origin, that is 0 comma 0 comma 0. What is the surface area is if it has four sides. Two sides are parallel to each other and these two sides are parallel to each other. That I know. Okay, to calculate the surface area, this vector and this vector, if I calculate cross product of it, then it will give the surface area. Or I take I take a kind of if if this is the one surface that is slant and another surface is also slant. Okay, in that sense, if this is slant, then if I draw from here a vertical line, it will hit x axis, and there length of it is 1, x is 1, then this is the height. Similarly, this side, okay, this side, from this point, if I go down and it hits y axis and length is 1, then height is some z. Okay, what is the length, what is the equation of this vector, and then this vector from this side I am saying. If I do cross product, then I can get the value, the surface area of the small one. The way we started calculating the line length, we tried calculating the line length. First, the idea was to calculate the line length of this line, where end point is x comma y. I took x as 1 and go up, and then calculate the vector form of this. Then calculate the magnitude of this vector, multiply it by x. This is what we are doing. Similarly, if the surface is like this, then take x equal to 1 and then go up, and take y equal to 1 and go up. Okay, then somewhere if x equal to 1 and y equal to 1, it will, that is on xy plane, it will hit this point P. At point P and 0 origin, it will make a rectangular region. Find the area vector of that rectangular region. That is better word. If I take x-axis 1 on xy plane, y-axis 1 on xy plane, there is a point 1 comma 1 comma 0. That is on xy plane. From there, if I take vertical, it will hit at a point. This point is P, this is origin. Okay, from P, now calculate a line, get a line that is parallel to this axis. Get a line that is parallel to this line. Now calculate the area of this. Calculate the area vector of this. Then calculate the magnitude of this area vector and then multiply by full, full, full this x, not this line. Full this x and full this y. Okay, okay, the way we did here, you take line x equal to 1 and calculate the vector and then calculate the magnitude of vector multiply by x. This is the line. This is the surface now. Okay, calculate the area vector of unit surface that is formed because of it is mapped from the unit surface on xy plane. Calculate the surface area vector, get the magnitude and multiply by this x where it is coming as like this and this y where it is coming like this. Okay, then how it would be? What is this line? Then this area vector is cross product of two side vector. If I take this side vector, from my side it is like this, or this side is. If I try to calculate one side vector and then the other side vector, one side vector, if this is x, the height is z by x. Okay, if this is x and this is z, then if this is 1, this height is z by x. Similarly, if I go in this direction, if this y is 1, then height is z by y. One vector is I plus z by xj. One vector is j plus z by yj, z by yk. One is x and k. One is y and k. So one is I plus z by xk. One is j plus z by yk. If someone does cross product of these two, then it will result in the area vector. Here we calculated simply area vector in this point is 1 comma y by x, that the length vector is I plus y by xj. Similarly, their area vector is I plus z by xk cross product with j plus z by yk. This cross product will be now minus z by xi minus z by yj plus k. This is called area vector. Area vector in the sense, if someone calculates the unit vector of this, it will give the direction of the area. But if you calculate the magnitude of this, it will give the actual area. Okay, now we got the actual area when in xy plane it is mapped, this area is mapped with the area that is 1. What about full xy plane where x is x and y is y? Multiply it with the x and y. Then it will come as z by x whole square plus z by y whole square plus 1 square root into x into y. It is very well when z by x is constant number. Z by y is a constant number. If that is the case, then it will go all right. Otherwise, if it is algebra variable, then someone is in problem. Then we will transform into differential calculus, altogether integral calculus. Then it becomes dz by dx whole square plus dz by dy whole square plus 1 square root into dx and y, d of xy plane. Okay, that is the scenario. Anyway, the first one what we did that was I plus z by xj, I plus z by xj. If I transform into differential calculus, one it becomes I plus dz by dxj. Another becomes j plus dz by dy. I'm sorry, I plus dz by dxk, and one is j plus dz by dyk. I plus dz by dxk is same as d of xi plus yj plus zk by dx. Same thing. Other is j plus dz by dyk is same as d of xi plus yj plus zk by dy. Same thing. Now, what is xi plus yj plus zk? That is p. That is this end point. That is p. That is x comma y comma z. So if I am trying to calculate the surface area of this where one is origin and other point is P, that is x comma y comma z, this full surface area, then it is dp by dx cross dp by dy, because dp by dx is I plus dz by dxk. dp by dy is j plus dz by dyk, where where a kind of P is xi plus yj plus zk. Make sense? This is called area vector. If I know area vector, but area vector only when x is 1 and y is 1. Please support us. Okay, this is something that is not available in any of the book. No one talks about area vector, this and that. They come to a conclusion that no one can understand. You check any big any better to best book, the way they start delta x tends to 0, delta y tends to 0, and this and that, and then it maps there and consider this tends to 0, then you can take out, and then no one can understand it. Okay, the concept of line vector when x equal to 1, concept of area vector when x equal to 1 and y equal to 1, or in xy plane area is 1. If I can take xy plane as single independent component, not required x-axis and y-axis, xy plane as single independent component where area is 1. In that case, what is the area vector? If I'm trying to calculate the length of a line where x equal to 1, then it hits here. What is the vector rotation? Similarly, in 3D, if this is the surface, this is xy plane, I take on xy plane, I take area as 1, that is x1, y1, and go up and hit this surface. If this is the small part of this big part, if this is the small surface, what is the area vector of this surface? Then calculate magnitude of this area vector, then multiply it by x and y. That is the point P, x and y. Okay, that is same as dp by dx cross dp by dy, where P is the end point, xi plus yj plus zk. dp by dx is I plus dz by dxk cross j plus dz by dyk. Okay, dp by dx cross dp by dy is same as d of p by dxy plane. Okay, that is calculation of what is calculation of the line vector when x equal to 1 and y equal to y by x. If this is x and this is y, if this is 1, then this is y by x. This vector is dp by dx. If this point is x comma y endpoint, dp by dx is I plus dy by dxj. Same. Okay, so this dp by dx here, if p is position vector, then dp by dx gives the line vector. Similarly, if p is position vector of the area, then dp by dxy plane. There it was dp by dx. Here it is dp by dxy plane. dp by dx means per unit, 1 unit of x change brings how unit of change in p. Similarly, dp by dxy plane says 1 unit of xy change brings how many unit of change in p, that is area. Okay, so dp by dxy plane is same as, or rather I would say, dp by dx cross dp by dy. That is the net area vector we got when x equal to 1 and y equal to 1. If I try to find the analogous to the 2D to 3D, in 2D we had dp by dx. Then here it is dp by dxy plane. That is same as dp by dx cross dp by dy. dp by dx cross dp by dy, that is equal to dp by dxy plane, is the surface area of, this is the surface area vector when x and y is 1 and 1. Then if x and y is 1 and 1, then dp by dxy plane is the surface area vector. Then what is the net surface area? Then dp by dxy plane is magnitude. Now we know the surface area of the surface when x is 1 and y is 1. Then what will happen if x is x and y is y? Full plane. Multiply with the x and y. The net surface area is dp by dxy plane is magnitude into x into y. Okay, dp by dxy plane will be a function of x and y. If it is function of x and y, then full is dependent upon independent component, that is xy plane. Xy plane is independent here. dp by dxy plane, its magnitude is dependent upon xy plane, that is on right side, that is x into y. X into y is xy plane. If someone settle it down, Then one is dependent and another is independent, and in between multiplication is there. So integral calculus. So dp by dxy plane is magnitude into d of xy plane. Now integration of xy plane from beginning to the end. Xy plane beginning is 0 comma 0 and end is x comma y or alpha comma beta, whatever someone takes. This is called this is called the complete solution in the terms of algebra variable where something is dependent upon something else. So net is dp by dxy plane its magnitude into d of xy plane where xy plane is 0 comma 0 to alpha comma beta or x into y. Okay, now we'll break it. dp by dxy plane is dp by ds cross dp by dy. Its magnitude d of xy plane I can break as dx dy. And then this xy 0 comma 0 to alpha comma beta I can break it into kind of x is from where to where and y is from where to where. Okay, someone can try to find out for the sphere anyway. This is called primitive calculus. Primitive calculus in a sense that whatever the pseudocode we had written for the surface area, that was I plus z by x j, z by x k cross product j plus z by y k. This cross product will give the surface area when in xy plane area is 1 and then multiply by x into y. This is called pseudocode. Now the pseudocode will turn into calculus when I know that z by x, z is dependent upon x. Z by y, z is dependent upon y because z is dependent component and x and y are independent. This division will transform into differential calculus. So I plus dz by dxk cross product j plus dz by dyk into x into y. Now x into y being independent and full this term is dependent into d of x into y. This is primitive calculus. Modern calculus says is if you are trying to find a surface area of something, surface area, what you know? Someone would ask, what you know? I know surface area of a rectangle. That I know. Okay, very nice. What you're trying to get? You're trying to get surface area of this sphere, right? Then do one thing. Okay, take where is your x-axis and y-axis? This is x-axis and this is y-axis. This is x-axis, this is y-axis. This is z-axis. If this is like this, then chop it along x-axis, make a infinite chop. Okay, then chop it along along x-axis, make a vertically make an infinite chop like this. Now along the y-axis, make infinite chop like this. Then full the surface area will be chopped like a small area piece, and it won't be a curve when delta x tends to 0. Take any now this full surface area, if you chop along x-axis and along y-axis, it will make a small area region. Take any area region where the any area region, consider any area region. It is curve, right? It is curve. But that I have chopped it into so many parts, infinite parts, that curve will look like a flat line. Make sense? If this is a curve, Earth is a flat. Earth is not a curve. Anyone asks how you see the Earth, he will say it is a flat. But someone goes 100 kilometers above the Earth, he will see it is a round. Means if you go near to it, it will look like a flat. Similarly, if I chop it into infinite side, that curve region, what area region I get one chop, that will be like a flat. It will be so small. If it looks like a flat, then what is the area of that? Similar way, calculate area of the all chopped surface and add it. That is the area, right? This is we want surface area. Chop it in a so many cut that each section will look like a flat surface. Now you know the how to calculate surface area of the flat surface, right? Yeah, I know. What is that? That is I plus z by x k cross product. Consider one, if I chop it, one surface area is like this. Okay, that is flat. Now the surface area is cross product of this vector and this vector. This vector, if I see, then this is x-axis, this is z-axis. If this I see, then this is y-axis, this is z-axis. If I talk about this, if I take x as 1, then height will be z by x. This one vector will be I plus z by xk. Similarly, this will be j plus z by yk. Okay, now, okay, then multiplied by x, full x and y. Where x is 1, it is I plus z by xk. When y is 1, it is j plus z by yk. Cross product, that will give the surface area where x and y 1. Take the magnitude and multiply by full x and full y. Okay, if full x is delta x and full y is delta y, because it is a chopped one, out of infinite chopped area, it is one of them. Then in that sense, the cross product of two sides and its magnitude will give area, and then multiply by the full x and y. What is that? Then that is I plus delta z by delta xk, bracket cross product with j plus delta z by delta yk, multiply by delta x delta y. That is the area of one section. Then represent it. If this is x-axis, I chop it into n part. I am talking about the ith part. Similarly, if I chop y-axis in n part, I am talking about the ith part. X-axis ith part, y-axis ith part. Wherever it goes up and whatever the area it is showing, that area I am talking. Okay, what is the area of that? That is I plus delta z by delta x ith section k, cross product with j plus delta z by delta y ith section k, and then delta x delta y of the ith section. Now, like ith section, you sum it for everyone, you get the full surface area. Now, summation I equal to 1 to n I plus delta z delta z by delta x ith k vector cross product with the j plus delta z by delta y ith k vector. Take the cross product and get the magnitude of this, and then delta x delta y ith term. If you add it as per the calculus, if you keep adding everything, it becomes delta z by delta x becomes dz by dx. Delta z by delta y becomes dz by dy. That is the primary fundamental of calculating the integration. And then delta x delta y becomes dx dy. Now full becomes 1 plus dz by di plus dz by dx k, j cross product j plus dz by dy k. Okay, get the magnitude of this dx dy. Now x is from one location to other location, y is from one location to other location. Mind blowing, amazing. We'll take example of this to spare. In this is one was the primitive calculus that we calculated earlier, and this is modern calculus where we did the thing through delta x and delta y and delta z, and then you add for everything and make delta z as dz, delta y is dy, and delta x as dx. This is modern calculus. Everything we have done, we'll take some example and we proceed with a different tedious example in calculus. So calculus is nothing but try to, whenever someone lands up into a problem, how to solve it, then write a pseudo code with the simplest case, the generic code, and there division you wherever you see the division, then change it to differentiation, and whenever you see multiplication, change it to integral calculus. Make sure that in multiplication one is dependent upon other, and in division numerator is dependent upon denominator. That's it. And then take limit from lower limit to higher limit, how it is proceeding, and you get the result. We will see with a mind-blowing more example. This will take example and then we will see other example. Don't mind supporting us. +91 is the India country code. 94831 60610 is the telephone number. 94831 60610 is the telephone number. +91 is the India country code. Mind blowing, right? dp by dxy. You see in any book, dp by dx cross dp by dy, they will say this is area vector and or velocity vector. Calculate the magnitude of it. No one will say this is the area vector per unit area on the xy plane. That is the biggest thing. That's why you are multiplying with the x and y. Anyway, okay, so we'll proceed on this.